Still thinking about the function from our last two videos. Now we're just asked to find the first ordered partials of this function. And so, well, let's see what happens. Let's first find the partial with respect to x. Well, I'm gonna have to use the quotient rule. So x squared plus x plus y squared all squared, and then I have the bottom times the derivative of the top minus the top times the derivative of the bottom. And thinking about this derivative with respect to x here, get 2x plus 1. Oh, I think we could tidy that up just a little bit. X squared plus x plus y squared all squared on the bottom. 2x squared plus 2x plus 2y squared minus 4x squared minus 2x. The two x's cancel off. I got a like term in the x squared part. So I got minus 2x squared plus 2y squared all over that denominator. And that's a good final answer, but I'm going to factor out a minus 2 and just let this be x squared minus y squared on top. All right, so now I need to go through and take the first partial with respect to y. All right, we'll start off with the quotient rule again. Though I think there's actually a more clever way of doing this. All right, so x squared plus x plus y squared all squared, and then on the top I have that bottom, x squared plus x plus y squared. And the clever among you know I didn't even need to write that down, because when I go to take the derivative of the top with respect to y, that comes out as a 0. Minus the top times the derivative of the bottom. Well, now the derivative of the bottom just 2y. Little less to have to work with here. Minus 4xy all over x squared plus x plus y squared squared. I have my first and my second partials. I could even write down the gradient vector if I felt like it. Minus 2x squared minus y squared. Ooh, that's right. Okay. Just double checking my signs there. I got a little worried, but it seems like that all worked out. Oh, and just for the heck of it, let's say someone asked me to find the gradient vector evaluated at the point 1, 1, just for fun. All right, well, in the x component, that's easy to compute. I'm going to get 0 over 9, so just 0. And then the y component, I got minus 4, and 1, 1, and 1 still make 3 squared is 9. And so now I found the gradient vector evaluated at that point 1, 1.